All right, I'd like to explain the L-706 bore alignment system now. The L-706 bore alignment system has a number of different components, beginning with the L-706 lacer. We have an L-111 stand, we have an L-102 beam translator, we have A514A adapters, A514B adapters, and the A514C adapter. Legs for each one of the adapters. It comes as a kit. So I'll explain the different components. But first off, what do we do with this system? So a lot of diesel engines, locomotive engines, compressors, air compressors, huge air compressors. We even have a system for doing reciprocating compressors where they have a segmented bore set, if you will. It's not a complete bore, it only has a top and a bottom, but we have a system for that as well that we can explain later on. To begin with, the L-706, this is the L-706 lacer. This lacer has to be 2 micrometers on here. We have what we call a vertical adjustment and a horizontal adjustment. Okay, the vertical adjustment will move the beam. When I have the lacer, there's a level on the top and the bottom. I have it leveled up this way. This is the vertical adjustment. This is the horizontal adjustment. The purpose of the levels are so if I have this turned, my vertical adjustment is going to go at an angle. It's going to make it real difficult to bring it in. So we keep this straight up and down. Then the horizontal adjustment will change the beam from side to side. It's battery operated. We have 3 position switch, off. We have another position for a continuous beam and a position for pulse beam. The pulse beam, the beam will blink and we eliminate background light that way. There's a nominal settings on here. So when I set these micrometers at the nominal setting, the beam comes out of here, basically so I have equal adjustment up and down vertically and side to side horizontally. It just centers it up kind of. Not centers it up, but changes the angle so it's pretty much perpendicular to the face. The beam comes out where this 3/4 inch nub meets the 2 1/4 inch diameter. This is where the beam originates. So when I turn these micrometers, I'm steering the beam the angle only. It never changes its position here. It is held in magnetically. This is the 111 stand. This fits on the magnet. This is a magnet here. So we can set this down on the surface. We put the laser beam into the unit and we turn it from side to side until it's level. And then the beam is going to be coming out this side. So we can adjust this up and down until the beam is somewhere close to the center of the bore. In other words, I could have this here in front of this, and I can move this up and down until I'm fairly close to the center of the bore. Now, when I use this thing, this top will come right off of here, okay, for storage purposes. When I get this out, I want to first, using these micrometers here, I want to adjust this so these beams are fairly parallel. The segment, it just kind of centers it up so I have equal adjustments. When I put this back on top of the base, there's a tooling ball here in this corner. That tooling ball is where this pivots from. So it pivots like this, and it pivots like this. But this is the corner that pivots from. We want that tooling ball on the top. We never want to put it on upside down. We want it on the top. And I also want the heavier part of this, where the micrometers are sticking out, I want that over the top of the magnet. That just makes this much more stable. Another feature of this magnet is these posts will come off of here and I can bolt them on the top. So if I have a face, I could put the base here and my post would be coming up. If I didn't have any surface here, like say a bore with a flange, and I have no place to set that, so I can reconfigure this so I can put it right on the face of the flange and be able to get through the bore. We also have what we call a beam translator, an L-102 beam translator. This beam translator, with the lacer in here, we can steer the beam, the angle of the beam, vertically and horizontally. But if I was to steer that so both of these read the same number, let's say, and I'm off 50 thousandths, then I can shift this by tipping this mirror and turning this mirror. I can move that beam straight up, straight down, or straight sideways without changing the angle. So I can actually get that beam right on the center of these bores. This fits over the post. Slide down and bring it right over till it touches, and then we'll square that up similar to that. This also, we want to center this up like we did this before we start. There's a gap here. We want to center that gap up so it's equal around. This tooling ball in the corner goes on the bottom. Back to the A514A, the A514B, and the A514C. You have a series of different legs. So we can adjust legs for these adapters, put different legs in here. We can put legs in here. This will fit a bore from 3.75 inches to 6.75 inches by changing the legs. And we have a gauge that we can set that leg length with. The A514B adapter will fit a 6.5 inch bore to a 17.5 inches by putting different legs in here and setting the gauge up and setting the legs for there. The 514C will fit a bore 17 inches to 40 inches. We have a whole different gauge for the 514C that's quite a bit longer. If you buy the 514C, the whole kit, then you'll get the longer gauge that you'll use for all three adapters. If you don't buy the 514C, you're going to get the smaller gauge that works with the A514A and A514B. This is the target that we use. This target, each of these adapters have like a flange on here, and there's a dowel pin. Okay, that's the side that the target goes in from. So this will slide through the adapter, and we're going to put the dowel pin in the little slot there, and then we have a knurled nut that we screw on here. That holds the target firmly into the adapter. Of course, we'll have the legs in there at the time. There's a level on the top, so when we put this in the bore, we want to level it. So our vertical axis is straight up and down, our horizontal axis is straight side to side. Same like the lacer I explained, we want it straight, our vertical axis straight up and down. Well, if this is turned, our vertical axis is running at an angle and makes things much more difficult. Now, if you need, say I said this will go down to 3.75 inches. If you need to go down smaller than that, we do have an A512 STA, we call it, an A512 STA. That'll go down to 2.5 inches, 2.5 to 6. We change the legs in that. They're not adjustable legs, but they're interchangeable legs. Let's talk about the readout. This is where we get the numbers from the target. The laser hits the target generates some numbers, and those are sent to here via a wire. The target plugs into this readout. The readout has a battery, so we charge the battery. The battery is good for about 9 hours of continuous on. So if you have it fully charged, probably no need to worry about the charger until you're finished. But this is a radio version of the readout. We still plug the target into this, but because it has an antenna, this will send a signal to a laptop computer if we want to use the software to document the alignment. So we can do that wirelessly. You can have a readout that doesn't have the wireless capability. It's just a standard readout. This readout, again, we have a vertical number and a horizontal number. This target gives us numbers both vertically and horizontally. Since we have vertical and horizontal adjustments, we can measure these bores in both directions at the same time. We don't have to turn the target, if you will. Which reminds me, these targets also, I haven't mentioned, these are self-centering targets. These are self-centering. There's no moving parts. When I put the legs in here, when I set this up and before I put it into this bore, I'll explain exactly how this target works. But I did not mention earlier, these are self-centering targets. So the bore could get bigger or smaller, and we're still going to be measuring the center of the bore. Okay, so we have vertical and horizontal numbers. We can show our numbers in metric or inches. We have basically an absolute and a zero mode. We're never going to use a zero mode for this. I want to forget about the zero mode, but it has that capability for using different types of targets. We have a low battery indicator on here, so if the battery gets low, this will start blinking and you'll need to plug it in. When you plug it in, it'll start charging and the charging indicator will come on. When it reaches full charge, the light's going to turn off. It's going to shut off the charging circuit so you don't overcharge the battery. On the back of this, we have a kickstand that is an option. So with this, there's a magnet here, so this is magnetic. So you set it down, it's on a surface, you can't knock it off. Or you can pull out the kickstand and you can stand it up so you can see it. Before I get started also, I want to kind of describe on the board what we're going to do. So why we have all these different components. Why do we have this beam translator? Why do we have these adjustments? So if I have a series of bores, as I have here, if I set up this lacer out here, it can be running off like this. And remember, the lacer doesn't move at this point. This is where it pivots from. So we put a beam translator here. This is what this is. So we can steer this beam so it comes through here like this, but now it may be too low. It may be too low. So if we tip this beam translator, the way it works, if the beam comes in perpendicular to it, it passes straight through. If I tilt that, the beam will rise and it'll exit parallel to its entrance. That's the way the beam translator works. So we can raise that up and we can pass that beam through the center of this bore and through the center of that bore, and then we can measure all the bores in between to see if they're all in a straight line. Let's get started. With the kit, we also have a set of dial calipers. The calipers are to measure the bore. So these bores are all the same, so I'm gonna turn this on and I'm gonna measure the bores, zero it. I need to know what size this bore is. This bore is 4 inches. So I'm going to set this at half of that, or 2 inches. Now it's not a very real necessary to be right down to 1,000th. We can actually deviate by about 20 thousandths on the length of these legs. What's critical is all the legs are the same length. The gauge itself is machined out in here. So one part of the caliper is going to go right to the center of this. So we're actually going to use the radius of the bore, and I'm going to bring this in, so I set this dimension at 2 inches and then tighten this set screw. So I know my legs now are all set at the same length. And I want to make sure it didn't move, so I'm going to... Okay, so now I have the gauge set. Now, because this is a 4-inch bore, I know I can use the A514A because this will go to 3.75 inches. So it's just a little bit larger. So I'll use the shortest legs. Now if you look at this adapter, these legs are offset. So when I put this on, where the legs go is going to be lower than the other one. These are the ones that I want to put in first. I'll put those in, and then I'll turn this over and I'll do the other two. But also looking at the adapter, on one side there's two set screws or two tension screws. On the other side there's only one. This one set screw is the side that we want to use. So after I've set that, there's a dowel pin that fits in the dowel hole here. And I'm going to slide this adapter onto the post. And I'm going to put this leg, and I'm going to put that so when I turn this and bring it up against that dowel pin, it pushes that leg in. And then I'm going to pick this up, and I'm going to turn it and put another leg in. And when I put these legs in, there's a ball, like a ball on the end. I want that ball facing out. When I spin this, it pushes the leg in. Now I'm going to take the adapter off and I'm going to turn it over so the other two legs will be on the bottom. And I don't want to over tighten these bolts, but I want them snug so the legs can't move. Okay, I have all the legs set. I'm going to insert the target. The target's going to go in here, and the dowel pin is going to fit in the slot. We put on the knurled nut, and then we screw the handle on the back. This is a weighted handle. And you see it's at an angle, so when I put this in the bore, I'm going to tilt it a little bit, slide it in, release it, and the weight of the handle is going to hold it into the bore. Now, these are self-centering adapters. There is no moving parts here. But when these are designed so this bore can get larger or smaller by 20, 30, 40 thousandths, and it'll still remain in the center because this pivots, and we're measuring right here at that pivot point. So I'm going to put this into the near bore, and I like to start right at the front of the bore, and using the level on here, I want to make sure I'm level in this direction, side to side. Okay, so that's the target setup. Now I'm going to take the 111 stand and I'm put this on the base. And I'm going to do a course alignment here. So first off, I'm going to take the laser beam and I'm going to set these at nominal settings so I have equal adjustment in all directions. And I'm going to put this in the stand and I'm going to level it from side to side so my vertical is straight up and down. Plug in the battery pack. And this has a fixed beam and a pulse beam. We're going to put this in a pulse mode so the beam is blinking. And I can see where the beam hits here, but to make things easier, I'm going to plug this target into the readout. And then I'm going to turn the readout on by pushing the button on the bottom. And then I'm going to just loosening these thumb screws. I'm going to move this down so I can see I'm off to the side. And then I'm going to cheat a little bit, and I'm going to take a magnetic base, and I'm going to set in front of this, up against this, so I can move this base straight sideways. without changing the angle. And I'm going to slide this over, watching that readout until I'm somewhere close to 0. I don't care, 10 thousandths is good. I'll get my vertical numbers a little closer by moving the whole thing up and down. Tighten the thumb screws. So now I'm real close to the center on the near point. And I'm going to take this to the far point. And again, I want to keep it level from side to side. And down there, see, I'm not even hitting the target, but I can see where it's at. If I can't see it, I'll put my hand in front of it, or I'll take a piece of paper and I'll see where it's at. And using the course adjustments on the 111 stand, I'm going to adjust that beam sideways until I go into the opening. And I'm going to bring that down somewhere as close to 0. This is the course alignment. We're not fine-tuning yet, we're just doing a course alignment. Then I'm going to take it back up to the near point. What I need to do is I need to get this within about 10 thousandths, 20 thousandths before I put the beam translator on. So now I'm really good vertically, but I need to move this horizontally. So I'm going to loosen the base and slide it back over. Because I was not even hitting the target down there, it's changed here a little bit. See, now I'm only off 11 thousandths. So again, using the course adjustments, I'll bring these numbers right down to 0. Because I'm so close, I'm just going to go right to 0. The course adjustments and then the fine adjust. That's what the fine adjustments are for, so we can easily get this last couple thousandths out of here. Okay, now I'll bring this back up to the near point. And I'm within 2 or 3 thousandths. So now I'm going to put the beam translator on and I can fine tune this. Slide it down the post, tighten the thumb screw, and I'm using the beam translator. I'm going to tip this forward or back for the vertical and turn it side to side. Now, just to explain how the beam translator works, if you're interested, this is a piece of glass. That's all it is, a piece of glass, and it's ground perfectly parallel on both sides. So basically, if that beam hits that perpendicular, it goes right straight through it. But if I tilt that piece of glass, it'll hit that and it'll shift down and it'll exit parallel to its entry. So I can shift the beam straight up, straight down, straight sideways without changing the angle. When I'm up close like this, it's very easy. You're seeing how quick it was bang, bang. I'm within a couple, 3 thousandths. The farther I get this away, the more difficult it becomes to do that course alignment. So always get this up as close to the near bore as you can. You'll have a lot easier adjustment. Now, the beam translator has this handle on the top that if I turn this, I change my horizontal numbers. If I tip it one way or the other, I change my vertical numbers. And then there's fine adjustments here. So I'm going to fine tune here to 0. So anytime I'm in this near bore, I'm going to translate that beam. When I didn't have the translator on, I slid the base or I moved it straight up and down. When I go to the far bore, I use the angular adjustments and I tilt that lacer. I steer that lacer on the far bore. Another thing to mention, when I put this in each bore, I want to put that in the exact same location every time. Because this bore could be tilted a little bit, one way or another. It could not, in other words, just not parallel with the center line. So a different location is going to give me different numbers. And I'm starting out, as you see, in 3 decimal places. I'm going to get it to 0 in 3 decimal places, and then if I want better accuracy, I'm going to change this readout to 4 decimal places and go right down to the 10,000ths of an inch. So in the fire bore, now I'm within 2,000, so I'm going to use the micrometer adjustments, and I'm going to steer the fine-tune micrometers and steer this to 0 vertically and horizontally. Now there may be a little change here, but in thousandths may not. So I'm within 1. So now I'm going to change this to 4 decimal places, get right down, because even though this shows 1, I might only be at 5/10 because this is rounding up. So I'll go to the menu, and I'll get to the resolution, and I'll change this to 4 decimal places. And then I'll fine-tune my zeros. Fine-tune the right down to 0. Okay, now I'm going to take it back to the fire point, the fire bore. Again, using the fine adjust, take it right down to 0. Okay, so I'm within 1/10 from end to end. I'm in within 1/10,000th of an inch. 0 here, 1/10 down here. Now I can measure everything in between. So now, before I do that, I've always put this in the back of the rear of the bore here, the back of this far bore, and the front of the near bore. So I want to see what kind of angle I have in this bore. I can put this one in the rear because I know I'm 0 in the front. If I look in the rear, I can see this is tilted down 2,000ths of an inch in the back. So the bore isn't quite parallel to the center line. The same way here. I measured in the back, and here back here, I'm pretty much at 0. So if I move this to the front, I can see I'm 2,000ths low in the front. This is the opposite. So we can actually measure the angle of the bores that way as well. Now I can go to the bore in the middle, and I'm just going to put it right in the middle of the bore. And I can see this bore is 29,000ths low, and it's 15,000ths to the left. The way I know that, because this is a negative number, the target is low. And I always do that by standing behind the laser, looking into the target. Stand behind it. If I stand here, plus and minus is backwards. I always want to look into the target. Plus is high, minus is low. Plus is to the right, minus is to the left. So if I wanted to fix this, what I'm going to do is I'm going to take this target out, and I'm going to shim this up 29,000ths. And I'm going to shim it over this way 15,000ths. So I'll take the target out. And I'll move this out of the way. Put 15 on the side. Now we'll see what. Now I put it in there. And within the thousandths up and down, I missed it a little bit sideways, but I know why that is. It's just the fixture. But that's how you make the adjustment. You have live readings. If I didn't have to take this out, I could leave the target right in there and make the adjustments and watch the numbers. So that's how you do bore alignments using the external 706.